I'm going to take you through the features of the AIM graphical interface, used to automate the satellite acquisition process for any of the Holkirk series of antenna systems. Before we start, there are a few assumptions that we will make. The first assumption is you will have already entered the data for the reference and the target in the satellite screen. The second is that you have set up your LNB parameters in the installation screen. And finally, you have selected a reference satellite that is in the satellite database on the target screen. I am now going to take you through the main action buttons you will need for the acquisition process. Acquire. This will initialize the satellite acquisition. Stow. This has two functions. One to stow the antenna into the safe position for transportation, and the second is to provide an emergency stop for the automatic movement of the antenna. Other buttons will include the log function that will open a new window with system operational logs, and the emergency stop. There is also a screen lock to lock all the controls on the screen. As we go through the acquisition process, progress will be tracked and displayed on the Octo item readout. To start the acquisition process, push the Acquire button. The first action in the process is a deploy. This command will drive the antenna to a set position so the feed arm clears the fairing. It also returns the pole and azimuth positions to 0. During the process, the icon will be orange showing the action is in process. Once the process has been completed, the icon will go green. Once the antenna has successfully completed a deploy, it will start the initialization phase. During initialization, the antenna will read all the sensors and instruments required to calculate the position of the satellite. It will read the GPS, so it knows the location of the antenna. It will read the heading from the magnetometer, so it knows which way the antenna is pointing. It will also read the pitch and roll sensors, to determine the terrain conditions the antenna is sitting on. It will then interrogate the satellite database, to find the orbital slot of the reference satellite, and calculate the position of the azimuth, elevation and pole. Once the elevation has been calculated for the reference satellite, the antenna will drive 20 degrees above the geostationary arc, and calibrate the DVB receiver in a clear sky measurement. Using the information for the target screen, the AIM will then set the correct polarization of the reference satellite, and drive to the start of the search window. The AIM has a dual drive speed system, which allows the azimuth and elevation to be driven simultaneously. This gives a smooth and precise motion for fast and accurate identification and peaking. At the start of the azimuth search window, the elevation will be correct, and will be perfect for the geostationary reference satellite. The pitch and roll sensors will compensate for any tilt or gradient the antenna may see, and maintain a constant elevation across the whole sleep window. Once lock has been detected, AIM will drive through the signal until lock is lost. The system will then drive azimuth to the calculated position in the center of the lock. To obtain maximum signal strength, the AIM will then perform a peak function on the reference signal, before comparing the information held in the satellite database to confirm we are pointing at the correct satellite. If your reference and target satellite are different, once the reference has been successfully identified, AIM can then drive the antenna to the target satellite position, changing the polarization and LNB settings if required. Once again, to achieve maximum signal strength on bore site, the AIM will perform a peak function on the target satellite, and will compare information to confirm we are locked and acquired on the correct satellite.